Good morning, students. So today also I am taking class for class 12. The subject is mathematics. So this is the continuation chapter, that is inverse circular function. In the last class also we were doing the same topic, that is inverse circular function. Okay. So now this is from page number 99 of XII book, Higher Mathematics for class 12 by XII. So page number 99, exercise 4, same exercise is there. So each question carries 5 marks in this case. But this type of question will come in 4 marks section, right? So question number 27, you have to solve, right? So the question is sin inverse x minus sin inverse y is equal to pi by 3 and cos inverse x plus cos inverse y is equal to 2 pi by 3. So there are two variables here, x and y. You have to get those values of x and y. If there are two variables, then there will be two equations. Okay. So if there are two variables, there will be two equations to solve that equation, right? That means you have to get the values of x and y in this case. So what is the first equation here? Sin inverse x minus sin inverse y is equal to pi by 3. And what is the second equation? Cos inverse x plus cos inverse y is equal to 2 pi by 3. Okay. Now in this case, you have to convert either sin inverse x and sin inverse y in terms of cos inverse x and cos inverse y, or you may convert cos inverse x and cos inverse y into sin inverse x and sin inverse y respectively. But you have to change only one equation, not both the equations. Okay, that means let us keep it same. First equation, that is sin inverse x minus sin inverse y is equal to pi by 3. Let us change this cos inverse x and cos inverse y in terms of sin inverse x and sin inverse y, so that we can solve that two equations, right? So here the first given equation is, now this is the solution. First equation is sin inverse x minus sin inverse y is equal to pi by 3. This is equation number 1, right? So now what is the second equation here? Again, what is the second equation now? Cos inverse x plus cos inverse y is equal to, it is 2 pi by 3. So let us change this cos inverse x and cos inverse y into sin inverse x and sin inverse y. Now you know the formula, isn't it? So how can you change cos inverse x and cos inverse y in terms of sin inverse x and sin inverse y respectively? Okay. So in this case, you have to use this formula. You know this, sin inverse x plus cos inverse x is equal to pi by 2. That means you should get the formula for cos inverse x from here, isn't it? So what is cos inverse x is equal to? So cos inverse x is equal to pi by 2 minus sin inverse x. Similarly, what is cos inverse y is equal to? Pi by 2 minus sin inverse y, isn't it? So in place of x, instead of x, you have to write down y. So therefore, cos inverse y is equal to what? Cos inverse y is equal to, this is pi by 2 minus sin inverse y, right? So cos inverse y is equal to pi by 2 minus sin inverse y. So let us put these values of cos inverse x and cos inverse y here in this equation, right? So this is actually second equation. Okay. So what is cos inverse x in this case? It is pi by 2 minus sin inverse x plus, what is cos inverse y? It is pi by 2 minus sin inverse y, which is equal to, this is your 2 pi by 3. Is that clear? Now, what is pi by 2 plus pi by 2? It is 2 pi by 2. 2 gets cancels, you get only pi. Here minus is taken common within bracket. What do we get? Sin inverse x minus into minus plus, you have to change the sign. Sin inverse y is equal to, this is 2 pi by 3. Okay. Now let us take this pi to the right hand side. Okay. Or minus within bracket sin inverse x plus sin inverse y is equal to 2 pi by 3 minus pi. Is that clear? Next, what will you do? Let us simplify the right hand side. So left hand side remains same, that is minus within bracket sine inverse x plus sine inverse y, which is equal to, what's the LCM here? 3, isn't it? So below pi there is 1. So this is LCM is 3. So you will get 2 pi minus 3 pi divided by 3. 3 ones are 3. 3 is the LCM. So the numerator will be 2 pi minus 3 pi, right? So or minus within bracket sine inverse x plus sine inverse y is equal to, what is 2 pi minus 3 pi? Different sign, you have to subtract it. So it is minus pi by 3. Is that clear? That is 2 pi minus 3 pi is pi, but you have to write down the sign of the greater number, that is minus pi by 3. So here pi gets cancels. So what do we get? It is sine inverse x plus sine inverse y is equal to, this is your pi by 3. This is the new equation that is derived from equation number 2. Let us mark it equation number 3. Now forget about this equation 2. Let us solve equation 1 and equation 3. Now in order to get the values of x and y, you have to solve equation 1 and equation 3, right? So write down solving what? Equations 1 and 2. Solving equations 1 and 2. Not 1 and 2, 1 and 3. So let us solve these equations 1 and 3, right? So therefore sine inverse x, let us write equation 1, sine inverse x minus sine inverse y is equal to what? It is pi by 3. Is equal to pi by 3. Next, what is the third equation? It is sine inverse x plus sine inverse y is equal to, this is pi by 3. So one is equation 1 and the other one is equation 3. Now we can solve it. Either you can add or subtract. You may add them. If you add, you don't have to change the sign. But if you subtract, you have to change the sign. But let us add them. So you don't have to change the sign. So here sine inverse y gets cancels. What is sine inverse x plus sine inverse x? What is a plus a? 2a. Likewise, what is sine inverse x plus sine inverse x? It is 2 sine inverse x, which is equal to, what is pi by 3 plus pi by 3? It is 2 pi by 3. It is 2 pi by 3. So in the numerator, in the numerators on both the sides there is common, that is 2. So you can cancel this 2, right? So write down in the next step. So what do we get in the next step now? What do we get? Therefore sine inverse x is equal to pi by 3. Sine inverse x is equal to pi by 3. Is that clear? Now take sine inverse to the right hand side, it becomes sine. So x is equal to, this is your sine pi by 3. Sine 60 degree, that means, what is the value for sine 60 degree? It is root 3 divided by 2. Is that clear? So we have got the value of x. But in this case there are two variables. You have to get the value for y also. So you can put this value of x is equal to root 3 by 2 either in equation 1 or in equation 2 or in equation 3. So let us put these values of x in equation 1. So right now putting the value of x in equation 1, right? So therefore sine inverse x minus sine inverse y, sine inverse y is equal to, this is pi by 3, right? Or now in this case either you can put the value for x which is equal to root 3 by 2, or you may put the value of sine inverse x. Just now we got sine inverse x is equal to pi by 3. So directly you can put the value for sine inverse x is equal to pi by 3 in this case. No need of putting only the value for x here. Again you have to simplify it, isn't it? So directly you can put sine inverse x is equal to pi by 3. So let us put here pi by 3 minus sine inverse y is equal to pi by 3, right? So let us get the value for minus sine inverse y, that is pi by 3 is taken to the right hand side now. So or minus sine inverse y is equal to what? Pi by 3. It is pi by 3 minus pi by 3 goes to the right hand side, becomes minus pi by 3. Is that clear? So here pi by 3 gets cancels, or minus sine inverse y is equal to 0. Now you don't have to write minus sign because there is 0 on the right hand side. Actually this minus means minus 1, and you know that minus 1 is not equal to 0. So we can write sine inverse y is equal to 0, right? So next, what is the value for y now? Or y is equal to, when this sine inverse goes to the right hand side, to the opposite side or to the right hand side, it becomes sine. So it is sine 0, or y is equal to, what is sine 0? That is 0. So we have got the answer. So which are the answers here now? You have to write down the answer now. So x is equal to root 3 by 2 and y is equal to 0. So these are the answers. Is that clear to all of you? That is x is equal to root 3 by 2, and what is y? It is 0. So this is the answer. So you can copy it. We'll do the next question now. So now we will do the next question, that is question number 28. So it is solve. So you have to solve this equation. What is the equation here? Sine inverse ax upon c plus sine inverse bx upon c is equal to sine inverse x, where the condition is also given there. A square plus b square is equal to c square and c not equal to 0. So this is only one equation because one variable is there. If there is one variable, you have to, if only one variable is there, then there is only one equation. That is, x is a variable here. So you have to get the value for x in this case. And the condition is given, wherever you get a square plus b square, you have to put is equal to c square. And also it is given that c is not equal to 0. Right? So let us solve this given equation. Right? So this is the form you can use, sine inverse x plus sine inverse y form, and right hand side is sine inverse x. So let us use the formula on the left hand side. Okay. So what is the formula there that you can use on the left hand side? It is sine inverse x plus sine inverse y, right? So it is sine inverse within second bracket. What is x? X is ax by c here. Then root over 1 minus, what is y square? Y square means bx by c whole square, isn't it? So it is b square x square upon c square, right? That is sine inverse x is ax by c here into root under 1 minus y square. Here y square is bx by c whole square, that is b square by x square, b square x square divided by c square. Then plus sign. Now we have to write down y. What is y here? It is bx by c. Then within square root, what is 1 minus x square? It is 1 minus, what is x square here? Ax by c whole square. That is a square x square by c square. Here second bracket is closed. Right? So right hand side remains same. That is sine inverse x. So I think you have understood it. Okay. Now in the next step, what will you do? You can cancel sine inverse from both the sides. That means you don't have to write sine inverse in the next step. Okay. So what do we get? Ax by c, then root under 1 minus b square x square by c square plus bx by c root under 1 minus a square x square by c square is equal to only x. So I think you have understood it. Okay. So now what we will do here is, since x is common here, you can take it outside. Okay. So here x is taken common. So second bracket, a by c root over 1 minus b square x square by c square plus this is b by c root over 1 minus a square x square by c square, second bracket is closed, which is equal to x. So in this case there is x common, and on the right hand side also x is common, but you cannot cancel it. So why can't we cancel it? Because x may be equal to 0 in this case. यसमा x is equal to 0 पनि हुन सक्छ. त्यही कारणले गर्दा हामीले यसमा x लाई क्यान्सल गर्नु हुँदैन. So without cancelling x, take this x which is on the right hand side to the left hand side. So it becomes minus x, right? So or x within second bracket a by c root over 1 minus b square x square by c square plus b by c root under 1 minus a square x square by c square, second bracket is closed, then minus x which is equal to 0. So is that clear to all of you? Okay. Next. Now what will you do next? Here also x is common. So x is common within second bracket. What can we write? A by c, then within square root 1 minus b square x square by c square plus b by c root over 1 minus, it is a square x square by c square, right? So here x is common, right? These are the terms. Then minus 1. Then minus 1 second bracket closed is equal to 0. Is that clear now? Okay. So next. So these are the two factors here. You can write here either x is equal to 0 or this factor within second bracket is equal to 0. So let us write here either x is equal to 0 or a by c root over 1 minus b square x square by c square plus b by c root over 1 minus a square x square by c square minus 1 is equal to 0. So either this first factor x is equal to 0 or this whole second factor is equal to 0. Is that clear now? So now what will you do? So what will you do in the next step? Now we will take this minus 1 to the right hand side and you have to remove the square root from this left hand side and then you have to get the value for x, right? So one of the answers is x is equal to 0. So we have got one of the answers here, that is x is equal to 0. And again we can get the values of x from this equation also, right? So let us take this minus 1 to the right hand side and then you have to remove the square root, okay? Or a by c root over 1 minus b square x square by c square plus b by c root over 1 minus a square x square by c square, which is equal to 1. So is that clear to all of you? So now how will you do it now? So how can you simplify it now? So now let us take this one of the terms to the right hand side. Okay, so let us take one of the terms to the right hand side and then simplify it. Or now this is a by c, right? So root over 1 minus b square x square by c square is equal to 1 minus b by c root over 1 minus a square x square by c square. Is that clear now? So what will you do in the next step? In the next step, what will you do? You can square both the sides here. Let us square both the sides now. So write down squaring both the sides. Squaring both the sides. So squaring both the sides, what do we get? Therefore, this is a by c root over 1 minus b square x square by c square whole square, which is equal to, now within bracket, 1 minus, this is b by c, okay, then root over, it is 1 minus a square x square by c square, this is also whole square. That is, both the sides are squared, right? Next, what will you do? So you can simplify this left hand side. This square is for all these terms, isn't it? A square, c square, a square by c square within bracket 1 minus b square x square upon c square. Clear? Next, what is the formula here now? What is the formula that you can use here? This is a minus b whole square. What is a minus b whole square? A square minus 2ab plus b whole square. So let us write down here. What is a square? This is 1, whole square is 1. Minus twice ab. 2 into what is ab? That is b by c root over 1 minus a square x square by c square. Is it clear now? This is minus twice ab. Here a is 1. You don't have to write that one. What is b? b by c root over 1 minus a square x square by c square. Plus, what is b whole square? This whole term, that is the second term, is your b square. So it is b square by c square. Within bracket, this square root will be removed. 1 minus a square x square by c square. Is it clear now? Now let us simplify it once again. So I think I've understood it. You can copy it. Now we'll simplify it further, right? So now multiply them. Let us multiply it. Or a square by, this is a square by what? C square minus a square b square x square divided by c to the power 4 is equal to what? 1 minus, this is your 2b by c, right? Then root over 1 minus a square x square by c square, right? Is that clear to all of you? Then this is the second term, plus this is b square by c square. This is your b square by c square. Then it is plus or minus? Minus, right? This is plus and minus is minus. That is a square b square x square divided by, it is c to the power 4. So what can you cancel here? So we can cancel here. Some similar terms will be cancelled here. That is, this minus a square b square x square divided by c fourth will be cancelled. Is that clear? So next. So now what will you do in the next step now? So write down the remaining terms here. It is a square by c square, right? It is a square by c square. Then this is minus. When this goes to the right hand side, so let us keep this square root on the right hand side, but let us take this b square by c square on the left hand side. So it is a square by c square minus, it is b square by c square, right? B square by c square. Then this is minus 1. Is it clear now? This is minus 1, which is equal to, next, which is equal to minus 2b by c, minus 2b by c. Then within root, what is there? So within root there will be minus 2b by c, within root 1 minus a square x square by c square. So let us check it once again. This is a square by c square, right? Then plus b square c square comes here, becomes minus b square by c square. Then what do we write? This is minus 1. Okay, so when this plus 1 goes to the left hand side, it becomes minus 1, right? So let us simplify it further. What's the LCM out here? It is c square, right? So numerator will be a square minus b square minus c square. Clear? Which is equal to minus 2b by c. Then root on the 1 minus a square x square by c square. Is that clear to all of you? So I think you have understood up to here. So next, we can put the value for c square here. What is the value for c square there? It is a square plus b square. You can write here a square plus b square there, isn't it? So let us write it. Or, so let us write here a square minus b square minus within bracket. Instead of this c square, what can you write? A square plus b square, okay? So this is a square plus b square divided by, this is your c square, is equal to minus 2b by c. Within square root now, it is 1 minus a square x square by c square. Is that clear to all of you? Okay. Or let us simplify it further. A square minus b square, right? Minus a square minus into plus minus b square divided by c square, which is equal to minus 2b by c. Keep the right hand side as it is. This right hand side does not change. Root over 1 minus a square x square by c square. Okay. So here you can cancel these. A square gets cancels. You can cancel them, isn't it? So let us simplify it once again. Or, so what is minus b square minus b square? Minus 2b square divided by c square. Minus into plus is minus. So minus b square, same sign, you have to add them. Is equal to minus 2b by c and root on the, so this is 1 minus a square x square divided by c square. Is that clear? Now here, from both the sides, that is on the left hand side and on the right hand side, the common terms are there. The common terms are in the numerator as well as in the denominator. You can cancel them. So your minus gets cancels, 2 gets cancels, cn square gets cancels, bn square gets cancelled. So what do we get? b by c, right? Which is equal to root over, how much is it? 1 minus a square x square divided by c square. So we got this simplified expression, right? So we got this simplified expression. So what will you do in the next step? What can you do here? That means you have to square both the sides so that we can remove square root. So write down squaring both the sides. Squaring both the sides. So what do we get? B square by c square is equal to, on the right hand side also, square root will be removed. 1 minus a square x square divided by c square. Is that clear to all of you? So I think you have understood it. Now let us take the LCM here. B square by c square is equal to, what's the LCM? C square. So here c square minus a square x square. Okay. But here c not equal to 0 is given, isn't it? So you can cancel it. So you can cancel them. Okay. So or b square is equal to c square minus a square x square. Now let us simplify it. Okay. So now you have to get the value for x. So take that term containing x on the left hand side. That is minus a square x square, take it to the left hand side. So it becomes a square x square is equal to c square minus b square. Or what is the value for x square is equal to c square minus b square divided by a square. Is it clear to all of you? So I think you have understood it. Now again from given you can put the value for c square here also, isn't it? Again you can put c square is equal to what? A square plus b square, or x square is equal to a square plus b square minus b square divided by a square. Is it clear? So here b square minus b square gets cancels, you can cancel them. Or what do we get? X square is equal to a square by a square. So here also it can be cancelled. Is it clear? Next, or x square is equal to, what is 1 by 1? A square divided by a square is always 1, or you may cancel it 1 by 1, which is equal to 1. Or x is equal to plus minus root over 1, or x is equal to, this is plus minus, what is square root of 1? That is 1, right? So we have got the answers. So which are the answers here? So in the previous steps we get x is equal to 0 also. हामीले x is equal to 0 पनि पाएका थियौं हैन. So therefore x is equal to 0 is one of the answers, comma, and which are the answers here? It is plus minus 1. So these are the answers. So the answers are x is equal to 0 and plus 1 and minus 1. So these are the answers of that question number 28. So I think you have understood it. You can revise it at home. Okay, we'll do the next question. You can copy it. So now let's do question number 29. This is also solve. You have to solve. That means you have to get the value for x. So in this case only one equation is given. So there is only one variable, that is x. You have to get the value for x here. So what is the equation here given? 2 tan inverse within bracket cos x is equal to tan inverse within bracket 2 cosec x. So in this case you can simplify the left hand side using a formula there. You know the formula of 2 tan inverse x, isn't it? You know what is 2 tan inverse x? That is 2 tan inverse x is equal to, what is it? This is 2 tan inverse x is equal to, what is the formula? It is tan inverse 2x upon 1 minus x square. That is the formula. So on the left hand side you can use this formula. 2 tan inverse x is equal to tan inverse within bracket 2x upon 1 minus x square. Now I think you know this formula, isn't it? So instead of x there is cos x. Okay? Or let us use the formula on the left hand side. What is the formula? Tan inverse within bracket 2x. What is 2x here? 2x is cos x here divided by 1 minus, what is x square? What is x square here? It is cos square x, right? So it is 2x divided by 1 minus x square. So in this case x is cos x, which is equal to tan inverse within bracket, this is 2 cosec x. So let us keep this right hand side same. Okay, so right hand side remains same out here. So from both the sides in the next step tan inverse will be cancelled. That means we don't write this tan inverse in the next step. Okay, so or let us cancel this tan inverse. What do we get? 2 cos x divided by 1 minus cos square x is equal to, it is 2 cosec x. Is that clear? From both the sides you can cancel these two, which are in the numerator. This is common term, you can cancel it. You can cancel it because 2 not equal to 0, right? You can cancel it because 2 not equal to 0. Okay, so now it is cos x divided by, what is 1 minus cos square x? You know the formula, sin square x is equal to, now cosec x can be written in terms of sin x. That is sin x and cos x are opposite function. That is sin x is equal to 1 by cosec x, or cosec x is equal to 1 by sin x. So let us write here, it is 1 by sin x. Okay, so now in this case, since sin x is in the denominator, both sin x are in the denominator. That means sin x should not be equal to 0. If sin x is equal to 0, then this is undefined. That is, something divided by 0 is meaningless. That is always undefined. That means Here in this case sin x not equal to 0. That means you can cancel them. Sin x not equal to 0. That means in both the numerators sin x are common out here. So you can cancel it. Sin x ones are sin x, sin days, sin square x cancel with that. Square will be cancelled and you'll get one of these sin x. Okay. So or this is cos x by sin x, which is equal to 1 by 1. You can invert both the sides so that we can write it in terms of tan x, right? So or it is sin x by cos x is equal to 1 by 1. Actually, we are inverting both the sides. What is sin x by cos x? It is tan x, which is equal to 1. Now you have to get the value for x in this case, isn't it? Since it is tan x, right? Since the left hand side is tan x, tan of which angle is 1? Tan pi by 4. Or tan x is equal to what? It is tan pi by 4. Is it clear to all of you? Because you know that tan pi by 4 is always 1. So instead of 1, we write tan pi by 4. So from both the sides, what can you cancel? Tan may be cancelled, isn't it? So what do we get? X is equal to, this is your pi by 4. So this is the answer. Is that clear to all of you? So x is equal to pi by 4 is the answer. Okay, so you can copy it. We'll do the next question now. So now let's do question number 8. You have to prove that tan inverse within bracket half tan 2a plus tan inverse cot a plus tan inverse cot cube a is equal to 0 when a lies within pi by 4 and pi by 2, and this left hand side is equal to pi when a lies within 0 and pi by 4. Okay, so now let us prove it. So let us write down the left hand side. So left hand side is equal to tan inverse half tan 2a plus tan inverse cot a plus tan inverse cot cube a. Tan inverse cot cube a, right? So let us simplify the second and third term. So it will be easier for you to simplify the second and the third term, because in this case you can use tan inverse x plus tan inverse y. You should know the formula now. Okay? So is equal to tan inverse, this is your half tan 2a plus, what is the formula in this case? Tan inverse x plus tan inverse y, right? So tan inverse, what is x plus y? It is cot a plus cot cube a divided by 1 minus xy. What is xy here? It is cot a into cot cube a. This is tan inverse x plus y upon 1 minus xy, right? So let us simplify it. Tan inverse half tan 2a plus tan inverse within second bracket. So what is common in the numerator? It is cot a within bracket 1 plus cot square a divided by, in the denominator it is 1 minus cot to the power 4a. So here second bracket is closed. Okay, so we can simplify it further again. So next you can use the formula here, 1 minus cot to the power 4a, a square minus b square, isn't it? That is 1 whole square minus cot square a whole square. That is your a square minus b square. What is the formula? A plus b into a minus b. So let us use the formula here. Tan inverse half tan 2a plus tan inverse within second bracket cot a within bracket 1 plus cot square a, this whole divided by, so this is your a plus b into a minus b. So this is the formula. So what can we cancel here? This 1 plus cot square a will be cancelled, right? So which is equal to now in the next step. So write down tan inverse within bracket half tan 2a, right, plus tan inverse. So within bracket, what do we get? Write down the remaining terms, that is cot a upon 1 minus cot square e. Is that clear? So now again you have to simplify that second term. So you should convert this cot a in terms of tan a. You know what is cot a in terms of tan a? It is 1 upon tan a, which is equal to tan inverse. This is half tan 2a, right, plus tan inverse within bracket. What is cot a now? It is 1 by tan a divided by 1 minus 1 upon tan square a. Is it clear now? So you can copy it. Now we will simplify it further. So now let us simplify it further now. You can take the LCM here in the denominator, okay? So is equal to tan inverse. This is half tan 2a plus tan inverse within bracket. So numerator remains same, that is 1 upon tan a. It will not change. And in the denominator was the LCM. It is tan square a. Tan square a into 1 is tan square a, right? It is tan square a minus 1 divided by, this is your tan square a. Is that clear? So in the denominator, tan square a is the LCM. So isko माथि पटि चाहिँ कति हुन्छ? Tan square a minus 1, right? So now again let us simplify it. So which is equal to tan inverse half tan 2a, right? So here you can cancel tan a and square gets cancels. So when this denominator goes up in the numerator, it becomes upside down, isn't it? Plus tan inverse within bracket, it is tan a divided by tan square a minus 1. That means when the denominator goes up in the numerator, it becomes upside down. That is tan a divided by tan square a minus 1, right? So let us simplify it again. Now how can you simplify this second term again? You know a formula, that is tan 2x. What is tan 2x? 2 tan x divided by 1 minus tan square x, isn't it? So instead of x there is a, but you should write it in the form 1 minus tan square a first, because there is 1 minus tan square a, x is in the formula. So here also you can take minus common and you have to make it 1 minus tan square a. So is equal to tan inverse within bracket half tan 2a plus tan inverse within second bracket. It is tan a divided by minus is taken common. So this is 1 minus tan square a. Is that clear now? So now there is a formula 2 tan x. Here also you should write 2 here. That means you have to multiply and divide it by 2. So is equal to tan inverse within bracket half tan 2a plus tan inverse within second bracket. You write down minus first, then write down half into, to multiply tan a by 2, you have to write half, because that 2 should be cancelled. So it is 2 tan a divided by 1 minus tan square a. So which is equal to, this is your tan inverse half tan 2a plus tan inverse within bracket, this is minus half constant into, what is the formula for 2 tan a upon 1 minus tan square a? That is your tan 2a. So this is the simplified form. Okay, so you can copy it. We'll do further simplification now. So now let us do further simplification here. Next, now you have to prove this left hand side is equal to 0 when pi by 4 less than a less than or equal to pi by 2. But this left hand side is equal to pi when 0 less than or equal to a less than or equal to pi by 4. Okay? So now, let us simplify this second term because there is minus sign out here. Let us assume this second term, okay? Tan inverse within bracket minus half tan 2a. Tan 2a is equal to what? Theta. Right? So tan inverse take to the right hand side, it becomes minus half tan 2a is equal to tan theta. Now what is the method here? Take this minus sign to the right hand side. So it will be half tan 2a is equal to minus tan theta. Is that clear to all of you? Now let us write down this condition now. Okay? So since pi by 4 less than a less than or equal to pi by 2. Now you have to check in which quadrant does 2a lie. You have to check in which quadrant does this angle 2a lie. Okay? Since here it is given that a lies within pi by 4 and pi by 2. But you should check in which quadrant does 2a lie. So multiplying throughout the term by 2. Because we should get here 2a. We should get here 2a, isn't it? That's why multiply all the terms by 2. So it is 2 into pi by 4 less than 2a less than or equal to 2 into pi by 2. So what do we get? Pi by 2 less than 2a less than or equal to pi. That means this 2a lies within 90 degree and 180 degree. This 2a angle lies within 90 degree and 180 degree. That means tan 2a is negative, isn't it? Tan 2a is negative. Clear? So now in this case, you can write down this angle as negative angle. That is half tan 2a is equal to. Now this 2a lies within 90 degree and 180 degree. So tan 2a is negative. So you can write down that angle as the negative angle, right? That is tan of what? Minus theta. You can write it. Is that clear? So next, or now again take this tan to the left hand side, it becomes tan inverse. It is half tan 2a is equal to minus, which is equal to minus theta, right? Or let us take this minus sign to the left hand side again. So it is minus tan inverse within bracket half tan 2a. This minus sign is taken to the left hand side. It becomes minus. Now put the value for theta. Actually what was theta in this case? It is tan inverse within bracket minus half tan 2a. Is that clear to all of you? So we have got, that is tan inverse within bracket minus half tan 2a is equal to what? Minus tan inverse within bracket half tan 2a. Is it clear? Now what is left hand side there? So LHS, what was the simplified LHS? The simplified LHS was tan inverse within bracket half tan 2a. Then we had plus tan inverse within bracket minus half tan 2a. Right? So in this case, when the condition is pi by 4 less than a less than or equal to pi by 2, then we can write this minus sign outside because the value of this expression is minus tan inverse half tan 2a, right? Which is equal to tan inverse half tan 2a. So value for this expression is minus tan inverse within bracket half tan 2a. So both of these will be cancelled, which is equal to 0. That is proved. That is first part is done. Now we'll do the second part. You can copy it. So now let's do the second part. That is, you have to prove this left hand side is equal to pi. Left hand side is equal to pi when 0 less than or equal to a less than or equal to pi by 4. Here also, let us simplify this second term now. Okay. So write down, let again this second term, tan inverse minus half tan 2a is equal, let us write it as beta, not theta. Okay. Let us write down this second term as beta. Okay. Now what we will do here is, let us take this tan inverse to the right hand side. So it becomes what? Minus half tan 2a is equal to, this is your tan beta. Okay. So or half tan 2a is equal to minus tan beta. Now how to write minus tan beta? In the first case, we wrote minus tan theta is equal to tan of minus theta, because the condition was given as pi by 4 less than a less than or equal to pi by 2. Now the condition is given as what? 0 less than or equal to a less than or equal to pi by 4. Clear? Now in the next step, what will you do here? You multiply throughout the term by 2. What do we get? 2 into 0 less than or equal to 2a less than or equal to 2 into pi by 4. Or 0 2s are 0 less than or equal to 2a. This is less than or equal to, this is your pi by 2. That means this tan 2a lies in the first quadrant. The first quadrant of tan 2a should be positive. So you should write down the positive angle out there. Okay. So अब हामी positive angle चाहिँ कसरी लेख्छौं त? अघि चाहिँ हामीले डाइरेक्ट के लेख्यौ, tan of minus theta. अब हामी त्यसरी लेख्दैनौं. So or अब लेख्छौं half tan 2a is equal to minus tan beta is there. You should have the positive angle out there. So that's why you have to write tan of pi minus beta. So now this pi minus beta will be what? Positive angle, isn't it? Tan of pi minus beta will be positive angle. Agi थियो tan of minus theta. Minus theta is negative in the second quadrant, isn't it? But here 2a lies in what? In the first quadrant, and tan 2a should be positive. So to make it positive, minus tan beta can be written as tan of pi minus beta, and this pi minus beta will be positive. Okay. So in this case, pi is always greater than beta, or beta is always less than pi. So pi minus beta is greater than 0, because beta is always less than pi. Okay. Or now take this tan to the left hand side again. Tan inverse within bracket half tan 2a is equal to, this is pi minus beta. Okay. Let us get the value for beta here. Minus beta, take it to the left hand side. So it is beta is equal to tan inverse so now in this case, minus beta is taken to the left hand side, so it becomes beta is equal to pi minus tan inverse within bracket half tan 2a. Is it clear to all of you? So now we got the value for beta. Let us put the value for beta here. What is the value for beta in this case? It is tan inverse minus half tan 2a is equal to pi minus tan inverse within bracket half tan 2a. Is that clear now? So instead of tan inverse minus half tan 2a is equal to, instead of tan inverse minus half tan 2a, you should write this is equal to pi minus tan inverse within bracket half tan 2a. Clear? Now let us write down the left hand side now. So the left hand side was, what was the left hand side? It was tan inverse half tan 2a plus, next tan inverse within bracket minus half tan 2a, right? So first term remains same. Isn't it? So what is the value of that second term? Second term is this one. Tan inverse minus half tan 2a is equal to pi minus, you should write down this one for the second term, plus pi minus tan inverse within bracket half tan 2a. Is it clear? So you can cancel these two, which is equal to pi. So hence it is proved. So we have proved the result. That is, this left hand side is equal to 0 when pi by 4 less than a less than or equal to pi by 2. Or this left hand side is equal to pi when 0 less than or equal to a less than or equal to pi by 4. Again you can write down this question. Again write down this question because we have already proved it. Okay. So your question लेखेर फेरि तिमीले यसलाई के लेख्छौ proved भनेर यसरी answer लेख्नु. Write down the question again, but you have to write it as an answer, that is proved. Is that clear to all of you? So this is the answer. So you can copy it. We'll do the next question now. So now we will do the next question, that is question number 9. Prove that. You have to prove this LHS is equal to RHS, right? What is left hand side here? 2 tan inverse within bracket, within square root there is a fraction a minus b upon a plus b into tan x by 2 is not within square root. Bracket close is equal to, you have to write it in terms of cos inverse. That is cos inverse within bracket in the numerator a cos x plus b divided by a plus b cos x, right? So let us write down LHS is equal to 2 tan inverse within bracket root under a minus b upon a plus b, and this is your tan x by 2, right? So in this case you have to convert this expression in terms of cos inverse. That means you can write down the formula here. What is the formula that you can use here? 2 tan inverse x. Since there is 2 here, isn't it? So let us use the formula for 2 tan inverse x in terms of cos inverse. What is it? You should know that. That is cos inverse 1 minus x square upon 1 plus x square, right? So instead of x, what is here? This whole expression within bracket is the value for x, right? So what is x is equal to here? It is within square root a minus b upon a plus b tan x by 2. Is that clear? So let us use that formula, okay? So cos inverse within second bracket 1 minus, what is x whole square? This whole square, that is root over a minus b upon a plus b. This is tan x by 2 whole square. That is your x square divided by 1 plus a minus b upon a plus b. Then it is tan x by 2 whole square. So this is the expression. Is that clear now? So this is cos inverse 1 minus x square upon 1 plus x square, right? So next, which is equal to cos inverse. Now let us simplify it within second bracket 1 minus. Now because of this square root will be removed. That is a minus b upon a plus b into what? It is tan square x by 2. This whole divided by 1 plus square root whole square is a minus b upon a plus b. A minus b upon a plus b into this is tan square x by 2. Here also second bracket is closed. So we have simplified the term containing square, right? So let us simplify it. Now you should get a cos x plus b divided by a plus b cos x, right? So let us change it into sin and cos. What is tan square in terms of sin and cos? It is sin square by cos square, right? So is equal to, this is cos inverse within second. So now in the next step, what can you write? Is equal to cos inverse within second bracket 1 minus a minus b upon a plus b into, what is tan square x by 2? It is sin square x by 2 upon cos square x by 2, right? Whole divided by what? Similarly in the denominator 1 plus, it is a minus b upon a plus b, bracket close. Again, what is tan square x by 2? It is sin square x by 2 upon cos square x by 2. Is that clear? Now again you have to simplify the expression within second bracket, right? So is equal to cos inverse within second bracket. What's the LCM in the numerator? It is a plus b into cos square x by 2. In the denominator also, what's the LCM? A plus b into cos square x by 2. That LCM will be cancelled, isn't it? So directly what can we write? A plus b cos square x by 2. Next, minus a minus b into sin square x by 2. This whole divided by. This whole divided by what? Again here, a plus b into cos square x by 2 plus a minus b into, this is your sin square x by 2. So this is the simplified expression. Okay. Now let's simplify it once again. So let us simplify it. Is equal to cos inverse within second bracket. Let us multiply them. A into cos square x by 2. A cos square x by 2 plus b cos square x by 2 minus a sin square x by 2 minus to minus plus b sin square x by 2. Right? Whole divided by. Similarly, simplify the denominator. A cos square x by 2 plus b cos square x by 2 plus a sin square x by 2 plus to minus b sin square x by 2. Here also second bracket is closed. Okay. So now let us simplify it once again. So here you can take common from first and third. A is common in both the numerator and the denominator. And from second and fourth term, in both the numerator and the denominator, what is common? B. So is equal to cos inverse within second bracket from first and third. A is common. So it is cos square x by 2 plus sin square x by 2, right? Next, from second and fourth, what is common there? B. Within bracket cos square x by 2, cos square x by 2 plus it is sin square x by 2. Is that clear? Divided by. In the denominator also you can take common similarly. Okay. So you can take common similarly in the denominator also. That is, what's the LCM here? What's the LCM here? It is, you can take common, not the LCM. You can take common here, not the LCM, right? From first and third, what is common here? A. A is common, right? So here I have done mistake out here. From first and third, A is common, so it is what? Minus sign, isn't it? From first and third, A is common, so it is cos square x by 2 minus sin square x by 2. From second and fourth, what is common? Plus B. Within bracket cos square x by 2 plus sin square x by 2. In the denominator also, here A is common, within bracket cos square x by 2 plus sin square x by 2, right? And from second and fourth, what is common there? Plus B. Within bracket cos square x by 2 minus sin square x by 2. Here second bracket is closed. So is that clear to all of you? So now you should know the formula. So you should know the formula from submultiple angle, right? From submultiple angle, you can use the formula for these expressions. That is cos square x by 2 minus sin square x by 2. What is it? You can use the formula. Cos square x by 2 minus sin square x by 2. What is the formula from the submultiple angle? Its formula from the submultiple angle is cos x only, right? So is equal to cos inverse within bracket. What is here? A cos x plus b. You know that this is, what is cos square x by 2 plus sin square x by 2? Always 1. So b into 1 is always b. So you don't have to write 1 here. Okay. Here also a into 1 is a. because cos square x by 2 plus sin square x by 2 is always 1. So a into 1 is a, plus b into, what is it? Cos square x by 2 minus sin square x by 2. That is also the formula cos x. That is a cos x plus b divided by a plus b cos x. So we got this right hand side. Is that clear to all of you? So we have proved this LHS is equal to RHS using the formula 2 tan inverse x is equal to cos inverse within bracket 1 minus x square upon 1 plus x square. Is that clear to all of you? So you can copy it. We'll do the next question now. So now we will prove question number 10. So prove that tan of within bracket 2 tan inverse within square root 1 plus cos theta upon 1 minus cos theta bracket close plus tan theta is equal to 0. You have to prove LHS is equal to 0. Okay. So let us write down this left hand side. Right. Tan within bracket 2 tan inverse within root 1 plus cos theta divided by 1 minus cos theta plus tan theta. So in this case don't use the formula of 2 tan inverse x here, because we can simplify the expression within square root, because you know the formula of 1 plus cos theta and 1 minus cos theta from soft multiple angle in the trigonometry, isn't it? That is 1 plus cos theta is equal to 2 cos square theta by 2, right? 1 plus cos theta is equal to what formula? It's the formula 2 cos square theta by 2. And what's about 1 minus cos theta? 1 minus cos theta is equal to, it is 2 sin square theta by 2. Is that clear? So let us use this formula. Tan within bracket 2 tan inverse within square root. Write down the formula here. What is 1 plus cos theta? 2 cos square theta by 2. What is 1 minus cos theta? It is 2 sin square theta by 2, right? Then plus tan theta remains same. Is that clear? This is the second step. So we can cancel this 2, cancel it, which is equal to tan within bracket 2 tan inverse within square root. What is cos square by sin square? It is cot square theta by 2, right? Plus this is your tan theta. Is it clear? Which is equal to tan, now within second bracket 2 tan inverse. What is the formula for root of the cot square theta by 2? It is only square root will be removed, square will be removed, and you will have cot theta by 2. Second bracket is closed. Then write down plus tan theta. So copy it. Now in the next step, what will you do? So now in the next step, since this is tan inverse, you should convert this cot into tan. But you cannot write 1 by tan theta. You know that cot theta is also 1 by tan theta, but you should write it in terms of angles. That is, cot theta is equal to tan 90 minus theta. Okay? So right now, which is equal to, this is tan within second bracket 2 tan inverse, right? What is cot theta by 2 in terms of tan? In this case, you should write tan of pi by 2 minus theta by 2. That is tan 90 minus theta is cot theta. So what is the formula for cot theta by 2? It is tan pi by 2 minus theta by 2. Is that clear? First bracket close, second bracket close, then tan theta remains same. Then write down plus tan theta. Is that clear? Which is equal to tan within second bracket 2 into. Now what is tan inverse tan pi by 2 minus theta by 2? You know that tan inverse tan x is x. So similarly, it is pi by 2 minus theta by 2. Second bracket is closed. Then write down plus tan theta. Understood now? So which is equal to tan of within bracket. Now multiply by 2 there. What is 2 into pi by 2? Pi minus. What is 2 into theta by 2? That is theta plus tan theta. Is it clear? Now what is tan 180 minus theta? What is tan 180 minus theta? 180 degree minus theta lies in the second quadrant. In the second quadrant, tan is always minus. And you know that 180 means even multiple of 90. So tan remains as it is. So minus tan theta plus tan theta. Is that clear now? You can cancel both these two, which is equal to 0. Proved. So we have proved this left hand side is equal to 0. You have understood now? So you can copy it. We'll do the next question now. So now we will prove the next question. That is question number 11. Prove that tan inverse within second bracket there is a fraction. So what is that fraction? Root over 1 plus cos x plus root over 1 minus cos x whole divided by root over 1 plus cos x minus root over 1 minus cos x is equal to, you have to prove that it is pi by 4 plus x by 2. Okay. So let us write down this left hand side. Now you know the formula 1 plus cos x and 1 minus cos x, that we just did it in the previous problem, isn't it? That is in problem number 10. Just now we did the formula for 1 plus cos x as well as 1 minus cos x, right? Now you know the formula, right? So is equal to tan inverse within bracket, within square root. What is 1 plus cos x? It is 2 cos square x by 2. Plus root over, what is 1 minus cos x? It is 2 sin square x by 2 whole divided by within square root. Again, what is 1 plus cos x? It is 2 cos square x by 2 minus root over, what is 1 minus cos x? It is 2 sin square x by 2. Is that clear to all of you? So now you can simplify the expression within square root, right? Is equal to tan inverse, so within bracket, what is square root of 2 cos square x by 2? Only square root will be removed from cos square x by 2, isn't it? But square root cannot be removed from 2. Square root of 2 is root 2 into cos x by 2 plus, this is also root 2 into sin x by 2. Similarly in the denominator, root 2 into cos x by 2 minus, this is root over 2 into sin x by 2. Bracket is closed. Is it clear to all of you? Now again simplify it. What is common in the numerator? Root 2. What is common in the denominator? That is also root 2. So root 2 gets cancels. So what do we get? Is equal to tan inverse. So what do we get now? So it is cos x by 2 plus sin x by 2, right? This is the numerator. Divided by what is the denominator? It is cos x by 2 minus sin x by 2. This is, bracket is closed. Okay? But in this case you have to prove pi by 4 plus x by 2 only. So this tan inverse, cos, sin all are eliminated, isn't it? So since this is tan inverse, you should convert this fraction in terms of tan. So by which term will you divide? By which trigonometrical ratio will you divide both numerator and the denominator to get tan x by 2? That is, you should divide both numerator and the denominator by cos x by 2, isn't it? So is equal to. So directly I am writing it here. We are dividing both the numerator and the denominator by cos x by 2, isn't it? And you can separate the term also. What is cos x by 2 divided by cos x by 2? 1 plus. What is sin x by 2 upon cos x by 2? It is tan x by 2 whole divided by. In the denominator also, the expression is divided by cos x by 2. So we can separate the term. What is cos x by 2 upon cos x by 2? 1 minus. And what's about sin x by 2 upon cos x by 2? That is tan x by 2. So this is your tan x by 2. Okay. So now what will you do here? If it is tan inverse, you should write it in the form of tan of theta form. You may not get theta. You may get tan of a plus b like that also, compound angle, right? So you should write in the form of tan a plus tan b upon 1 minus tan a tan b. So instead of 1, what will you write? Tan pi by 4, because tan pi by 4 is always 1. So is equal to tan inverse within bracket. What do we write? Here you can write tan pi by 4 plus tan x by 2, right? So instead of 1 there, we wrote tan pi by 4. And in the denominator, there should be 1 minus tan a tan b. 1 minus, actually tan x by 2 is 1 into tan x by 2, isn't it? So instead of 1, what will you write? It is tan pi by 4 tan x by 2. Here bracket is closed. So instead of 1 here, tan pi by 4. Tan x by 2 means 1 into tan x by 2. And instead of 1 here, we wrote tan pi by 4. Is that clear now? So what will you do in the next step? So in the next step, you have to use the formula here, right? So the formula from the compound angle, you know that, right? Is equal to tan inverse. Now this is tan A plus tan B divided by 1 minus tan A tan B. What is the formula? Tan of A plus B. That is tan of pi by 4 plus x by 2. Is that clear? Now this is the form tan inverse tan x. If there is tan inverse tan x, what should you write? Only x. So in this case, it will be pi by 4 plus x by 2. So this is the answer. So we got the correct answer, isn't it? So it is good. Okay. So we can copy it. So this much is for today. So you revise all the problems we did today. Okay. So in the next class, we will do more problems. Right.